Okay, the following is a video over 3.2 notes, and this is the section where what we call derivatives. And we've been talking about derivatives for a while. The first thing I want to do is to talk about what a derivative is. And a derivative is a function that generates the slope of the tangent line at any x value. Okay. Now, let's talk a minute about what slope means, and I'm going to come back to this because we're going to talk about notation, about how do we write derivatives and what we can say. The one thing I want to talk about is the slope is the change in y divided by the change in x, okay? So delta y over delta x, okay? So when we talk about notation of a derivative, and this is how we write derivatives, okay? The main thing I want to do is, let's say I have a function f of x, okay? And what I want to do is I want to take this derivative. Okay, so the notation that I would use is I'd put this in parentheses, and I would write d dx of this function. When I use that notation, d dx, this is a verb. This means that I am taking the derivative. Okay? And so once I take the derivative, then I get these different forms of what we can say. And I've already showed you guys the most common one that I'll use is f prime of x, okay? Another way we can say the derivative is just y prime, okay? Another one that I'll use is dy dx. And then another one that I'll use is df dx, okay? I won't use df dx as much, but I will use these three interchangeably, okay? Now, these are all nouns, okay? These are the derivatives. These are the derivatives, okay? Now, one of the things is this term dy dx, okay? Remember when I wrote out here that slope is equal to the change in y divided by the change in x, delta y over delta x, okay? The d, this kind of means the same thing, okay? dy dx, all right? So all of these are different ways of writing the derivative. I use them interchangeably, but the main thing that I want you to see from this, not only the ways to write the derivative, but the idea of that this is a verb. The ddx means that I'm taking the derivative of a function, and that the nouns are the derivatives, okay? So this is something I got confused with, and when you break it up and you say that this is a verb and this is a noun, it really kind of helps explain exactly what we are doing, okay? So along with just the notation of how we name them, I want to talk about something called differentiability, okay? And this is, how do I say this? I want to say, this is when I say, where do we have a derivative? Where do we have a derivative? Okay. Okay. Another way of saying that is, where can I draw tangent lines? Where can I draw tangent lines? Okay. So what I want to do, what I want to also write, differentiability can be thought of, so can be thought of as smoothness. Smoothness. Oh, that just looks terrible. Sorry about that. Okay, so it can be thought of as smoothness. Smoothness. Okay. Another way we can say it as, oh gosh, what does it say? I like to think of it as, it involves continuity. Okay, so let's talk about that. These are kind of related, continuity. All right. So here's what I know. I know a function is differentiable. If a function is differentiable, then that implies, and this is implies, that a function is continuous. Okay? If a function is continuous, it does not imply, continuous, does not imply differentiability. Okay? So what I know is that if a function is differentiable, if we're given that information, then I know it's continuous, okay? However, if I know a function is continuous, I do not know if it's differentiable or not, okay? So, and when I use that word differentiable, okay, another way to think of it is where can I draw tangent lines? If it's not differentiable, okay, not differentiable, and I use DFF to say differentiable. If it's not differentiable, then I can't draw tangent lines, okay? All right, so I'm going to give you a couple of examples where we cannot have derivatives. So on the next slide, what I've got are these four words here. So when does a function not have a derivative? And that's when we have either a corner, a cusp, a vertical tangent, or a discontinuity. So I want to go through these real quick and talk about them. So I'm going to show all of these as graphs real quick. All right. These are all graphical representations. And then do something here. Okay, so what I've got these four different types of graphs that I want to talk about. I'm going to divide them all up here too. And so what I know is that let's say I have what's called a corner. Okay, so I've got this function here, and the function is kind of split up into these two different lines that intersect at this point. Okay, and so I'll call this, say, point 1, x equals 1. And I'll call this function f of x. Okay, what I know here is that the slope is equal to 0 here, and I'll just go ahead and say that the slope here is equal to 1. Okay, I know that the derivative here, f prime of x, is equal to 0, and here the derivative here, f prime of x, is equal to 1. I'll talk about how I got that here in a minute. But the question is, okay, what's the derivative? What's the derivative at x equals 1? Okay, and there is none. Okay, f prime of 1 is undefined. Okay, and the reason why is because the derivatives don't match at 1. My slopes don't match at 1. The slope here is 0. To the left of 1, I have a slope of 0. To the right of 1, I have a slope of 1. So I can't readily, I don't have a derivative here. The other thing is okay, how many different tangent lines could I draw here? Okay, if I wanted to come in here and draw tangent lines, I'll use the pink line to denote tangent lines. Okay, I can draw a tangent line there. I can draw a tangent line there. I can draw a tangent line here. Okay, where it's intersecting that point 1, 1, I don't have one tangent line. Okay, if a function is differentiable, I can only draw one tangent line. Here I can draw a bunch. Okay, it means it's not differentiable at 1. Okay, the other example that I have is a cusp. Okay, so let's say that I have a graph that is like an open parabola like that, and then all of a sudden it comes down and it does that. All right, this is a cusp. So at this point here, okay, what's happening on this point? And I'm just going to call this function g of x. Okay, so I'm going to call this g, that's not what I wanted, g of x. Okay, and I'm going to call this point 1. all right? So this is x is 1, all right? And so one thing I want to talk about is, because it's not as apparent as this one, if I come in here and I draw tangent lines, okay, at any one of these points, I can draw tangent lines of the graph, and the tangent lines get steeper and steeper and steeper. But then all of a sudden, you know, all these slopes that I have here, all these little tangent lines that I can draw are all positive. Then all of a sudden, it switches from very, very positive to very, very negative. Okay, and all of these little tangent lines, they don't agree at 1. Okay, the other thing that I could say is, all right, how many different tangent lines can I draw at this cusp? I can draw a number of tangent lines. Okay, so that's the other thing. So here's what I want to say. Okay, g prime of 1 is undefined. Okay, I can find at any other point along this function it's differentiable except at x equals 1. Okay, that's where it's not differentiable. Okay, I can do the same thing at a vertical tangent. And so I'm going to make a function here that has a vertical tangent. And so, and it may not be terribly exact, but at this point, okay, and I'll call this 1 as well, at this point here, the tangent line is vertical, okay, and a vertical slope is undefined, okay, so I'm going to call this h of x. Let me change to blue, okay, so this is h of x, and so I know this, h prime of 1 is undefined, okay, because my slope, m, is undefined. Okay. All right. Let's have a discontinuity. All right. Let's draw a graph with something like that. Let's just say that I've got a graph here, and let's say that there's a point here, and then there's a jump. Okay, and then it continues on. All right. And I'm going to call this, say, k of x. All right. At 1, okay, k of x is not continuous at x equals 1. So that means that k prime of x is not differentiable at x equals 1. Okay, so there's a lot of information going here. This is all just kind of information about derivatives, how we name them, where we have derivatives. In the next video, I'm going to show you how we can graph derivatives. Okay, hope you enjoyed this. Thank you.